Hello, my name is Dr. I'm a researcher on anatomy. In this video, I'd like to introduce a research tool called SegGraph, which is a segmentation tool for image sequence that combines automatic segmentation with interactive refinement function. This tool is available on GitHub and can be used for free. First of all, I'd like to explain the technology for constructing 3D polygon data from image sequence. Here we are showing CT images, but you can also use this technique from other types of image sequences, such as MRI, ultrasound images, or serial histological sections. The processes of creating 3D polygon data from image sequence is called 3D reconstruction. The technology like this has been around for a long time, but a need for it has been increasing in recent years. Let's consider the need to construct 3D polygon data from image sequence. In research, 3D reconstruction using serial histological sections is required in the fields of anatomy, histology, and pathology. For example, there is a need to visualize the fine structure of organs and the network of blood vessels and nerves to create 3D models of human development or animal development in embryology research, and to visualize the shape and spread of cancerous lesions in pathology research. In clinical medicine, 3D reconstruction using CT, MRI, ultrasound images is used for image analysis and is used in areas such as surgical planning and simulation, targeting in radiotherapy, and dynamic analysis of the musculoskeletal system in sports medicine and rehabilitation. Furthermore, as a recent technology, there is also growing need for 3D polygon data in the use of 3D printing and VR technology. In 3D printing for medical use, it is used to assist with surgical planning and pathological analysis, and in 3D visualization using VR, it is used for anatomical education and surgical simulation. However, there are also issues. Constructing 3D polygon data from image sequence is hard work. Why so hard? Because segmentation is so hard. What is segmentation? To answer it, let's check it out from the type of 3D data. There are two main types of 3D data. One is voxel 3D. This is also called volume rendering. The other type is polygon 3D. This is also called polygon 3D mesh or surface model. There are these two types of 3D data. The difference between them is whether or not 3D printing is possible. Volume rendering and voxel 3D cannot be 3D printed. On the other hand, polygon 3D allows you to print in 3D. So there are these kinds of differences. So how do we obtain these 3D data from image sequences? First of all, let's check out images in image sequence. They are two-dimensional images. They are typical pixel images. And pixel images are made up of small squares, each with its own color, and these small squares are arranged to form a single picture. This is the kind of image data. So it's easy to understand about voxel 3D. Voxel 3D is the 3D version of pixel images. So each of the small cubes called voxels is colored, and they are stacked up to make a 3D picture. However, this voxel 3D cannot be printed in 3D. There is another type of 3D data called polygon 3D that can be printed in 3D. Polygon 3D is also called a surface model, and it is a structure whose surface is constructed. That surface is made up of polygon mesh faces. Typically, these are triangles, and the surface of this three-dimensional structure is constructed from a large number of these small triangular surfaces. That is polygon 3D. And because the surface of this three-dimensional object is properly defined, it can be 3D printed. However, in order to construct this polygon 3D from a series of general pixel images, you have to go through one step. That's called segmentation. In order to obtain 3D polygon data, you need to perform a process called segmentation. Segmentation is the process of defining the boundary areas of each structure. If you don't do this, you won't know where the surface of this polygon 3D is. So we have to define the outline area boundaries of the structures in all the images. We have to draw the outline of each structure properly and color-code the area to show where it is. This kind of work is called segmentation. And this segmentation process is very hard. Segmentation of image sequence is extremely hard. Well, it's not so bad if it's just one image, but because it's a series of images, you have to deal with a large number of images, like 100 or 200. And in the past, this segmentation task of a large number of images have been done manually. But this manual segmentation takes a lot of time and effort. So for this kind of work, there are various image processing and segmentation tools that can assist with the work. One of these is the segmentation tool called SegGraph that I will introduce in this video. The idea is we want to automate this segmentation work using AI. Now, let's take a look at the types of image analysis by AI. The first one is classification. If you were shown the photo on the left-hand side and asked, what is this? You could classify it as a cat. The first step of being able to classify is called classification. And the second step is detection. This is the ability to detect the location of objects in an image. For example, you can detect that there is a dog here, a cat here, another cat here, and a duck here. And then the third step is segmentation. In this image, there is an object here, and rather than just roughly surrounding it with a square frame, the outline is here, exactly. This analysis is called segmentation. And of course, what we need this time is the third one, segmentation technology. And not just the segmentation of a single image, but there are also various AI models for automatic segmentation for videos. In a video like this, where there are horses, people, and other objects, the upper body is here, the legs are here, and the horse is here. The AI model can follow the contours and color-coded them properly. There are several AI models that can automate this process. To begin with, videos are essentially a series of images. By having a series of images that are similar but slightly different, and having these images followed by one after another in chronological order, you can create data that looks like it's moving. And image sequences are similar in this way too. In the case of image sequence, that image sequence that cut through the cross-section of a three-dimensional structure, the images that are next to each other are very similar, but they are also differ slightly. And these images are piled up one on top of the other to create their data for the cross-section of the three-dimensional image. So both of these are series of images. And the motivation for developing the segmentation tool SegGraph was the thought that we could use the AI model for video, also for a series of images. So I would like to introduce the features of SegGraph, a segmentation tool for image sequence that combines automatic segmentation with interactive refinement functions. First of all, the concept of SegGraph is not that it is an AI tool that completely replaces conventional work, but that it is a tool that uses this AI to complement conventional manual work and make it more efficient. In the past, all the segmentation work for image sequence had to be done manually. This has been done 100% manually, but with SegGraph, the majority of this work can be done automatically by AI, and the remaining parts, especially the important parts, are completed by combining the user-own checking and correction work. In other words, the AI does not replace all the work, but is positioned as a complementary tool. SegGraph has two main features: high versatility, 2, user-friendliness. First of all, SegGraph is an automatic segmentation tool that specializes in image sequence. It supports a wide range of image types, including serial histological sections, CT, MRI, and ultrasound images, and is not limited to any particular type of image. The core of this tool is the Segment Anything Model 2, a segmentation model developed by Meta. This AI model has already been trained, so there's no need to train it using your own dataset. It is a ready-to-use automatic segmentation tool that does not require prior training. In addition, in order to use AI-based machine learning tools in general, you need to have a certain level of programming knowledge and to set up the environment on your local PC. However, since SegGraph has been developed as a web-based tool, there is no need to set up the environment and no programming knowledge is required. Therefore, you can use it immediately. In addition, an interactive refinement tool is also provided. Although it is possible to use the results of the segmentation performed by the AI as they are, in research, it is important to check and correct them with your own eyes. For this reason, we have prepared intuitive correction tools. Furthermore, after segmentation, it is possible to easily reconstruct 3D images using the free software called 3D Slicer. It is also compatible with other 3D reconstruction software and can be imported and used. I would like to introduce some specific examples of the features of SegGraph. For automatic segmentation, we use a function called box prompt. When you want to segment the tissue structure shown as spinal cord, you can set a rectangular frame, box, that surrounds the entire object. In the second photo, these yellow lines, vertical and horizontal lines, have been drawn, and a rectangular box is set up to enclose the target object, spinal cord. If you set the 2 points, the left top point and the right bottom point of the box, the software will automatically extract the outline of the target object, spinal cord, and perform the segmentation automatically. Since we are dealing with a series of images, there is more than one image that need to be segmented. There are a large number of images, 100 or 200, but the automatic segmentation operation using the box prompt shown earlier only needs to be done once. After completing the automatic segmentation by box prompt using one representative image, the tracking function can be used to propagate the segmentation information to the other 100 or 200 images. It will continue to track each structure and perform segmentation, so automatic segmentation will be completed for other images as well. However, although it is possible to use the data as it is, there are situations where accuracy must be considered for research purposes. In such cases, it is necessary for researchers to check and correct the data themselves. Therefore, we have prepared easy-to-use interactive tools for the review and correction process. The concept is that this checking and correction process will ensure the final accuracy and reliability. The photos here show the checking and correction setup, and it is assumed that you will be using a computer with a touchscreen function or connecting the pen tablet to the computer. You will be using the left hand to operate the keyboard and your right hand to operate the touch pen. If you are left-handed, you can do it the other way round. Although we are assuming that you will be using a touch pen, it is also possible to use a mouse operation. The editing process is equipped with intuitive and interactive operations. For example, in the photo on the far left, there is a green-colored area. However, as a researcher, there are cases where the green area automatically colored by the AI is not enough, and you want it to be colored over a wider area. In that case, the users themselves will add the missing parts. Using the pen, draw the outline, and then press the Add Segmentation button to add a new area. This is like adding up. Also, in the third photo, the green segmentation area has spread too far down. If the AI has segmented an area that is too wide, draw the outline of the area you want to cut out and press the cut button to delete that area. This is like subtracting. In this way, while combining right-hand touch pen operation and left-hand keyboard operation, you can add and subtract segmentation areas repeatedly to interactively refine the data. The final segmentation data after this refinement process can be imported into 3D reconstruction software. 3D Slicer is a free software that is commonly used around the world as free 3D reconstruction software. The segmentation data exported by SegRef data can be easily imported to 3D Slicer. By importing this data, you can immediately start building 3D models. Of course, it is also possible to use this data with other 3D modeling software, not just 3D Slicer. If you want to try using or experimenting with SegRef, we have published an online manual on GitHub. The manual is available in both Japanese and English, so please access it via the link in the video description. Finally, I would like to introduce the workflow using SegRef. The workflow for segmentation and 3D reconstruction using SegRef consists of the following 3 steps. Step 1, automatic segmentation using AI. Step 2, user confirmation and refinement work using interactive tools. Step 3, 3D reconstruction using 3D Slicer or another software. I will show the case of constructing a 3D model from several histological sections as an example of workflow. First, launch the web user interface and uploaded the image files. Select a representative image. Use that image to set the box prompt and perform automatic segmentation. Press the tracking button to propagate the segmentation information to all images and complete the segmentation of all images. Next, move on to the refinement process. We use Microsoft PowerPoint as the user interface. PowerPoint is installed on the computers of many researchers and students, so it can be used straight away. Using macro function, you can automatically import the original images and overlay the automatically segmented data on top of them, as you can see. Using the macro and tools published on GitHub, the images are automatically converted into an editable format. After that, the whole image is checked and work proceeds while identifying the parts that need to be corrected. If there are any parts that are missing, they are added by drawing in the pen. And on the other hand, you can reduce unnecessary areas by specifying the parts you want to delete with a pen and cutting them out. In this way, you can carry out the correction work by moving up and down through the image sequence. You can draw the range to be added or deleted with a stylus pen and confirm the process with keyboard operations. When the refinement work is complete, you can export it. The images are converted and processed automatically, and the data is output as a segmentation area colored on a black background. There are two output formats, color images and grayscale images, and you will usually use the grayscale output. If you want to edit the image again after outputting it, you can return to the editing screen. You can import the segmentation data into software for 3D reconstruction, for example, 3D slicer, and construct a 3D model. After entering numerical data such as the slice interval, a threshold value is set from the grayscale data to extract the segmentation area. Once this process is complete, the data can be converted to 3D data immediately. Finally, the 3D data can be output as general 3D polygon data, STL file. The same process was applied to other cases, and a total of 15 structures were output as STL in this case. On 3D Slicer, it is possible to observe the details of each structure by coloring or changing the transparency. Since this data is output as Polygon 3D data, it can also be used for 3D printing or VR. This concludes the explanation of the workflow. We have introduced SegRef, segmentation tool for image sequence that combines automatic segmentation and interactive refinement functions. As an example of a workflow, we have shown the process of creating a 3D model from histological sections, but SegRef is a highly versatile tool, so it can be used not only with histological sections, but also with various types of image sequences, such as CD, MRI, and ultrasound images. If you are interested in using it, please access the online manual on GitHub via the link in the video description. All the necessary tools and download links are provided. SegRef is a free tool, so anyone can easily try it out. Also, if you use it in your own research and present or publish your research, I will be happy if you could cite the original paper of SegRef. That's all for this video to introduce the segmentation tool for image sequence, SegRef. Thank you for watching.